anticipate quite this many people, so there are 10 handouts, and they're basic. It's really just to get an overview. I suppose the point that I wanted to make is that I don't know whether most of you are familiar with the PISA study, which is done every 3 years, and they look over 500,000 students in 65 different countries, and it is very, very robust research. And as you've looked through here, I mean, does anything stand out to anybody? Any comments on what you've seen so far?
There's a problem with self-esteem.
Yeah, and it seems to make a difference. I suppose what I felt when I looked at it, I thought actually what you believe makes a difference. It makes a difference. It seems to me to be an equity issue because it's affecting girls more than boys. It's affecting people who come from poorer circumstances more than people who come from more affluent circumstances. And therefore, actually, how you feel about your capacity to do math is an equity issue. So it's very important. And I suppose then the second point I thought was, well, can you change it? Because some people say, oh, well, if that's your nature, that's your nature. And then, I'm not showing you, but I think there's robust research to say that what we believe about maths makes a difference. And then there's also robust research which says, actually, you can change. We can make interventions, these metacognitive interventions, which alter how people feel about maths. And again, there's fairly robust evidence for that. Some of you may be familiar with, I suppose it goes back to locus of control. We have Carol Dweck. Do people know about Carol Dweck and fixed and growth mindsets? She started, I suppose, probably in about the 1960s to identify the characteristics of people who are successful in their fields. And they tend to be people who attribute their success to hard work rather than to innate talent or ability. And so Joe Bowler and a group of people have sort of applied that to maths education. And you find the same thing. People who attribute their maths success to hard work are more likely to do well than people who attribute it to talent or gift or I'm just not a maths person. And in the UK, we have a tradition of having a very fixed mindset about maths. We are not a maths person. And I can say to myself, if I had not been pushed by a slightly lazy manager into teaching maths, I would also have characterised myself as not a maths person. But now I'm a maths missionary. These extraordinary changes happen. And so the question is, yes, well, I think the points are, yes, it does make a difference. There do seem to be interventions that make a difference. And so we had a go using, I don't know whether has anyone seen the How to Learn Math kind of course? It was a MOOC from Stanford University by Joe Bowler. Has anybody had experience of it? I don't know how it happened, but I stumbled across it. And so I saw it, and I did the teacher's course when it was free, probably 2 years ago, and then this year they put out a student course. And so we used the messages from this course, and it's all about how to change students' mindsets about maths. And really, it starts with busting myths. So what we did, I'll tell you, what we did was, we directly challenged the myths that there wasn't such a thing as a maths person. And we talked to them about intelligence. That intelligence, we now know, is something that is grown, it's developed. It's not something that you're born with. You can't put a dipstick in somebody's brain like they used to think you could with the 11 plus and say, oh, well, yes, here we go. It's developed, it's grown, and the characteristics of people who grow their intelligence are perseverance, are seeking challenge, not caring about making mistakes. And so we sort of encourage the students to think of themselves as potentially maths people. We called it growing your maths brain, and that's what we did. And through the year we tried to make if they say, oh God, I'm rubbish at maths, which anyone who's taught maths knows that's what they say. Or I can't do it. So, no, you just say, I can't do it yet. Or it's great you've made a mistake, because when you make a mistake it means your brain is growing. Great that you're a bit confused, because if you're not confused, you are not reforming your concepts. It's a vital sign of learning. Mistakes and confusion are vital signs. If you're not making mistakes, I'm not happy as a teacher, because it means your stuff you're doing is too easy. So we did that, and I went, because how long have I got? I don't want to take any of your time.
Got to 5 parts.
Got to 5 parts. Okay, so what we did was, we started it before this, we got the money to do this. So back in September, we adapted a questionnaire from the Joe Bowler site, which obviously been very well tested, and we asked them about their maths attitudes. And we also did ask them for 3 words that they thought of when they thought of maths. You can imagine it. And then we kind of went through. Actually, can I make this go on? I'll make this go on very. Oh heaven! Can you make it move on a slide?
Yeah.
How do I do it with
Left, right, or?
Okay, so this is from. Oh, that's it. Sorry, I still can't do it.
It is very slow, I think. I would use left,
So it was
right.
8 months when they looked at the research. Making metacognitive interventions has the same impact as feedback interventions. Obviously, it depends how you do it, you know, but it has the potential to advance students' learning by 8 months. So it's, you know, it's up there with feedback as one of the big ones. So if I do this, I don't know why I'm having so much trouble. Oh, there we go. Boom. I'm just going to go. So here we go. Here are some of our inspirations. Were, of course, Malcolm Swan, books by Joe Bowler, and towards the end of the year, if I've got time, I'll talk with you. I went right back to the 1960s and 70s and looked at the work of Bandura, and I think actually he has a lot of things to say about it. So we used this course, we got the ideas from it, and there are videos on it. So we started the year by showing the students the videos, but they're with an American, they use the word math, and it's all a bit gung-ho and American, and, you know, anyway, we stopped doing it because some of them quite liked it, but some of them were too critical, so this was the mindset. These are the sort of principles that, you know, the activities we tried to do and the intervention was based on. The idea that there is, and again, they're very similar to the sort of Swan principles. Come along. Oh yes, here was their first words about maths. And actually, through the year, they didn't. The interesting thing was, that was the thing, they all hated maths at the beginning. We showed lots of videos. Yes, and then they would write little things. And they don't all believe it. You know, here we got this written in one of the books where I was talking about how great mistakes are. Somebody has this picture. So again, we discussed it. And we talked about the reasons for the activities, the reasons why we were doing things. So there we go. It's hard, but I must do my best. Keep going. They wrote little notes to themselves. So you need to exercise your maths brain. Keep going when something is hard. These are just sort of ones I found in their exercise books. Can't remember what I was going to say there. I kept reminding them. Oh, well, the other thing is, don't go fast. I read a paper recently saying that the way we teach maths is a form of unwitting cognitive abuse. Somebody from the Open University. Because I thought, an unwitting cognitive abuse. And she says, yes, because it makes students feel anxious. If we're making people feel anxious and frightened, that is an abuse. And we do that because we make them go fast. All that emphasis on speed and also making them do things without understanding. Both of those are. So then on we go. That's the things I was telling them. Here we go, in the middle of the year, absolutely no difference with how they felt about it. The students themselves did the analysis of the words. They did a little content analysis and were broadly in agreement that most of the words were negative. And then, yeah, this was at the end of the year. When they did the words, which was a fairly public activity, they were still quite negative. And I actually asked one of the students, why did you say swindle? And he said, that's the government. The government changing what you had to do to pass. So these even after a year, they were still carrying with them this feeling, this very deep feeling. But then, I did it with my group. We did a comparison. It wasn't the same group. There were all sorts of computer problems, so I couldn't do my group at the beginning of the year, but I selected a group who I thought were pretty similar. So they were the same level, same courses, everything else, and looked at the differences. And there was a significant difference on 7 of the questions. They were significantly more likely to like maths, enjoy being challenged by maths, feeling confident they could tell if their maths made sense, less likely to fear maths frightened them, more likely to like complex problems, more likely to think maths is creative, and most miraculous of all, more likely to look forward to a maths lesson. So and talking to the students too, they said they felt that the mindset messages gave a kind of positive backdrop to the lessons. The mistakes were okay, don't hurry, help one another, you're all capable, we're growing our intelligence, etc., etc. So it does seem to make a difference, but it didn't make a difference actually. They weren't more likely to think that it wasn't important to be fast, because they used to say, well, we have to be fast in the exam. So they did have a few good points there. So anyway, I'm not going through all this. But, and also, although some of them felt less anxious, there still were people who felt anxious. Although there was a trend towards liking maths more, there were still some who didn't like it very much at all. It wasn't a panacea. Oh, there's somebody with you couldn't see it, but there was fractions with love hearts around it, which again I thought, oh, goodness me. At the beginning of the year, I asked them to think of the positive characteristics which they needed for their chosen field, which they could also practice when they did maths. And they came up with this, I found it a very touching list actually, of, and I didn't come back to it really, but next year I'm really going to work on this kind of development of these positive, virtues, human, whatever you want to call them, characteristics in the maths lesson. And just thinking that it's very important, I think, to have a very safe environment in the maths lesson. So always right from the beginning, I always say my rule is no one's allowed to say anything negative about anybody else. I don't care if they're in the room, outside the room, if you think it's true, not true, there must be no negative comments. And we all as a group go forward together, So, because they people who teach, imagine other people here who teach GCSE Resits, they come from different groups, don't they? So you've got the engineers, the beauticians, the horse people, this, that and the other, all in one room. And they feel a bit odd, actually, at the beginning of the year, don't they? So, oopsie, it's gone forward. So I probably can't never go back, can I? Can I ever go back with this? Do you know? No? Okay, what I'm going to tell you about, do you think I can go back? I've got 3 minutes, because the point I wanted to...
There you are. It will come back in a minute. It should show now.
Oh, there we go.
Yeah.
This. Is anyone familiar with Bandura's theory of self-efficacy? Perhaps people think it's old hat now, but as I was doing this at the end of the year, because my background is not maths, it's psychology, so it came back to me, that he says that our feelings about, or our beliefs, how we can do things, and obviously it's connected with our behaviour, belief to behaviour, comes from various things. One of them is persuasion, and I thought actually me giving the mindset messages is verbal persuasion, but he says that is not the thing that really changes how people feel, how competent they are. The most important thing is the mastery experiences, the experiences of success at a challenging task. And I think that's why the SWAN materials are so brilliant, because they provide, don't they, a constant thing to succeed at something which is challenging and which one can make actually a higher ceiling for them. Vicarious experience, how other people do. I thought, this is interesting too. I didn't say it, I just want to pass it on because it was the students found it useful. The other thing that affects us is how you interpret your physiological state. So within a maths lesson, a lot of people are feeling very anxious, aren't they? And so I told them about the amygdala, and that sort of deep in their brain is this P-shaped thing, the amygdala, and that is producing their feelings of anxiety. And when you go into an exam, the people who are going to do brilliantly and the people who are going to do terribly, their amygdala is producing the same sensations. So it's not the sensations that make the difference. It's how up here in the frontal cortex you interpret them. So if you interpret these feelings as, wow, I'm all ready for the exam and my body is producing adrenaline, so I focus down on the problem and all my forces are being brought to bear at the emergency situation in hand, then actually it's quite calming and you feel your body's going with you. But if you interpret them as, oh my God, I can't do this under any circumstances because I've got butterflies and I feel a bit sick, then actually that acts as a barrier. So I think old Bandura, he must be long dead now, has got a lot to help us with maths teaching. Thank you, is that it? I don't want to take any of your time. So, thank you, I haven't let any of you talk.